Okay, so in this slide we're going to talk about flowcharts and algorithms. And really these two are very closely tied together, and we'll see why in a few minutes here. So just to kind of remember where we're at in the problem solving cycle, we're going to kind of be living in the determine, produce, analyze phases for this slide. Really the takeaway here is that when we put things into flowcharts and we think algorithmically, we're kind of doing a number of different phases of a problem solving process. So an algorithm is simply just a step-by-step process for solving a problem or accomplishing something. It's a list or sequence of steps to be performed, possibly given by a flowchart or a diagram. So even there in the definition, it is very closely tied to flowcharts and even can be represented as a flowchart. If we look at a way of thinking algorithmically, a lot of times we'll have a starting point and we'll have inputs, okay, things that go into this process or into this algorithm, and based on those inputs we make decisions, and those decisions of course result in actions, and those actions may be to do some type of output, turn a light on, start a motor, turn a motor off, shut a valve, and of course maybe some feedback of the inputs back into deciding what to do next. Okay, and we may even eventually come to an end. Okay, but we might also just cycle around and around here indefinitely. But really, taking away from this slide is algorithmic thinking or algorithm is a step-by-step process. It has inputs, it has decisions, actions, outputs, and it can be represented as a flowchart, is what we have here. I mean, we've represented this algorithm, generalized algorithm, as a flowchart. Another example would be you get a phone call. Is the ringer turned on or off? Yes, no. Yes, phone rings. Does the user answer the phone? Yes, no. Right? So this is just a way to represent the action of whether you pick a phone call up or it goes to voicemail in a graphic. But this is an algorithm, right? It's a step-by-step process. You have inputs, you make decisions, you do things, or things are done. Other examples of algorithms are finding the shortest path through a maze, finding the most efficient route of a traveling salesman, artificial intelligence, machine thinking, the way machines are able to make decisions based on inputs, very often programmed and controlled by algorithms. The game 20 questions, you could envision this as an algorithm to get to the answer as quickly as possible within 20 questions. And so you're using inputs being the answers you get, determining what the next questions you're going to ask. Of course, algorithmic thinking and problem solving very closely tied together. Both are step by step, okay? And both, most people probably use and think this way subconsciously already, but we really want to try to do this consciously. We want to actually slow our thought process down so that we can have this process of thinking algorithmically, be able to be conscious and be able to put that down graphically or in a list and be able to visualize that. Because a lot of times that helps us to see the connections of a problem, see the connections and the results of a process, and be able to really graphically show that to really see maybe different solutions. So representing algorithms, a lot of times we use flowcharts to represent algorithms. Again, used to show step-by-step logical flow. If that's something you haven't heard me say yet in this presentation, then you may not have been listening. I've said it a couple times. Also, algorithms have one or more paths, and it's usually a bird's eye view of a process. It gives a really nice overview and shows, of course, bottlenecks. One thing I'll say about paths, the one thing I don't want to see, though, in our algorithms and our flowcharts are dead ends. So we come to one situation and we go to another situation and then we stop there, and there's no lines anywhere else. It's just dead ends. Okay. The only time we should dead end if it's actually the end. Okay, that should be the only time we come to a dead end, is that if it is actually the end of the process. Okay, so we should always be looping and connecting somewhere else. Oh, another example of a flowchart here could be lamp doesn't work. What do we do? Is the lamp plugged in? Yes or no? Is the bulb burned out? Yes or no? Okay. Of course, this now is a simple flowchart or algorithm, a step-by-step process of determining how to solve the problem of the lamp doesn't work. But I also want to point out that here's a dead end, here's a dead end. This is a kind of a dead end also. I mean, this could really feasibly flow into a totally different sub-process or sub-flow chart as well as these. So this is not very descriptive necessarily. I wouldn't want to see these dead ends on yours, but just giving you an example and then pointing out the things that I don't like about it. Some things I do love about this are that everything is horizontally and vertically aligned. So you have everything centered vertically, and of course I said that the first time backwards, and then horizontally as well. So you have these things centered both vertically and horizontally. You have clear distinction on the yes and no directions that need to be taken, with arrows pointing the directions. Okay, that's going to be important when we start setting up our flowcharts. I want to really strive towards a nice grid pattern and also a clear direction with clear yes, no, true, false descriptions. Also, we'll get to in a second, the diamonds definitely are questions. Okay, we need to add a question mark. And then the ovals or rectangles or rounded off rectangles, we're going to talk about differences of how we show those. But a lot of times those are things or actions that are taken or inputs. But diamonds are always going to be questions where you have to decide something based on an input or a previous step. Another example of a flowchart, a little bit different. Again, this is it's more of an ag process, and so you have a starting point here. You have some inputs along the sides. You have some processes going on. You have some results, some more inputs, maybe some feedback loops with some processes. So you got some things going on here. You have some directional flow. I'm assuming this is the end, right? But again, things that I like, it's clear what goes into the process, and it's clear where it loops, and it's clear how it flows. But it's a little unclear on that kind of the uniformity of shapes and sizes and maybe where the ending point is. I do like how it's vertically aligned very well, horizontally aligned well. We'll see when I do the demo. We're going to try and strive for a little simpler depiction of some of these arrows and directions and flow even as beyond this. Manufacturing process map, which you might see as well. This is another variation of a flow chart. Kind of more of a graphical, more of a pictorial version. Still showing a flow of a process and how things flow and how things are inputted and put into the process. This is an interesting example. I actually worked with a project where we were at the Harley-Davidson Softail factory, and we were doing RFID tags for the frames. After they got painted, they would be stored in a mezzanine hanger system, and actually got to work there for 2 weeks, up and down the line. Harley's going off the line every 2.5 or so minutes, so that's about the production rate that they had there. And of course, maybe a Harley is around, I don't know, $10,000 a bike easily. Softails, and so that's $10,000 going off that line every 2.5 minutes. But yet another version of a flowchart or process map. So if we look at the symbols and the shapes, ovals are always going to show a beginning or an end. Okay, start and an end. Arrows, of course, are going to show direction of flow. This is where some of these ones in the middle, the parallelograms, they're either inputs or operations. Rectangles denote processes. I'm going to be lenient on these two, but I'm really going to want to see diamonds being questions. Okay, and a lot of times they're going to be questions that have a if something, then something. So if this is true, then we do that. Or yes, no, true, false. Okay, so I'm going to really harp on this being questions. But we'll have some lenience in how we do this because everybody has a little different interpretation of how they do flowcharts. One topic I want to just touch on, we'll get more involved in this in the second half of the semester, is flowcharts to text-based code and the relationship that they hold to each other. This term pseudocode, basically sort of code, it's a textual representation of an algorithm or process flowchart. So it's using words to describe an algorithm or a program or a process. And usually it's a high-level version of code, and it's in words that we as humans understand. Even if we understand the programming language, it's even a simpler version of the programming language. It doesn't have all the syntax details, which is syntax we'll talk about again, but basically the specific ways of coding a program so the computer understands. And of course, it's like we've been talking, it's very close to the actual programming language, but it's a little bit different, easier for us to understand just off the cuff. And we can go between these pseudocodes and flowcharts, and we want to be able to bridge that gap because we want to be able to think systematically, step by step, and then translate that into a programming piece of code by the end of the semester to be able to accomplish a process, to be able to make a program solve a problem. So a quick example being this. We start with a input value, okay, so some generic input value, maybe from a temperature sensor. And we ask a question, is the input greater than 90? If it is, we want to throw a display up that says high temp, and then end. If it's not greater than 90, we want to say low temp, and end. Okay. So we come down, we have a nice vertical alignment, horizontal alignment, clear directional, clear which way we go based on our answer. We have a question mark here. We have a start. We have a stop. So we could take this picture now, and we could kind of describe it. You know, input is our temperature. If the temperature is above 90, then display high temp. If not, display low temp. Done. Right? And that's kind of a sentence structure of what the flowchart was just saying. Even taking this one step further, we could turn this into actual C code, which we'll do this in the second half of the semester, and it would look like this. It would look like specific lines of code, right, to take an analog input and make that temperature a variable, and say if temperature is greater than 90, print out over our serial monitor high temp. Otherwise, print out low temp. Okay, so we've seen here from going from a flowchart to a pseudocode text to the actual code that the computer would run and make function properly. So that's kind of the correlation or the relationship that flowcharts, algorithms, and programming hold. They're very closely related, and we're going to start in this section with just the flowcharts. We're going to end the semester with the programming. So let's go look at an example in Excel. And so at this point, I'm going to flip over to Excel, just going to run through a brief, just put that flowchart together I just showed you, and kind of show you how we go about doing that. So we'll open up Excel here. You can either type it in or click it if it's there. And we haven't really talked a lot about Excel. We'll get to that in the coming weeks, but first, this is the general page of Excel. We can do lots of stuff like calculate numbers. We can also make flowcharts. And so we're going to make a flowchart. So the first thing I'm going to do is I'm going to go to page layout, the top here, this tab. And the first thing I'm going to do is I want to take these grid lines away. Just so it's going to be easier for us to kind of visualize what we're doing. So we can go and click on that view grid lines and remove that. Then we're going to flip over here to insert. So we're going to insert some shapes. So we're going to insert, and if you hover over this here, this drop down, that's the shapes. I'm going to click on that. I have a whole bunch of options of shapes, and if you look here, we have an option for flowchart symbols. And so we have a lot more than we talked about, but really we're going to really focus on rectangles, maybe ovals, diamonds, and then maybe another version of oval. So the first thing I'll do is I'll start with this oval here. Click that, and I'll click and drag, and I can get my shape, however large or small I want. And then I can right-click, so I right-click and edit text, and I can type in start. And of course I can click on that and I can modify that, I can make that different. For right now, I'm going to just do that. Then I'm going to go back to Insert, and I want to do my box, or my rectangle rather, and of course, Edit and Input one value. And I can see I'm going to need to make these a little bit smaller. And then I can copy this, and a lot of times what I'll do is if I have a shape that I want to use multiples of that same shape, I'll just copy that same size. Okay, so I can keep that consistent. So I'll do a copy, and then I'll click somewhere else, and right click, and do a paste. Okay, and then I can go in here and double click, or I can go in here and right click and edit text. And I can say display low temp. So if we recall, we had these previously, and it looks like I need to make this a little bit bigger. Okay. And then I'll do the same thing, copy, come over here, paste, and I can easily do high temp. Okay. So remember my structure, I kind of had some of these things slightly organized. I'm just going to roughly rough this out, and I'll go back to Insert, and I'll put in my diamond for my question. So of course the question is, edit text, is input greater than 90, question mark. And a yes or a no leads me to low or high temp, and then the end, I can do a right click, copy, click down here, right click, paste. And just double click that and do end. Okay. So now I have my start, my input, my question, these two different options, and my end. And now what I want to do is add some arrows. So I can go in here and insert, and I can add arrows. Okay. And this is important to see when it goes to these little dots here. I want to hover over until I get to those dots, because I can snap, click and hold, and then once you get to the next one, release. If I do that, when I move this, those arrows stay connected. Okay, that is going to save you lots of time. So again, we'll do that again here. We'll insert, we'll go to arrow, and we'll go to hover. Once you see that square or that circle, click and hold, drag to see the next circle, and release. And now you've snap those to that. And so we can go and we can just continue to do this. And a lot of times this will eventually just pop up here, and you can just keep on running this. And a lot of times I'll use elbows, okay, if I want to do something that has a nice elbow to it, a nice 90. I try not to cut the corners. I try to keep things 90 degrees whenever possible. And so now I have my roughed out flowchart, start to end. But I want to get things organized horizontally and vertically. So let me start with going vertically. I'll select, hold down the shift, hold shift while you select all of these. And once they're all selected, we can come over to alignment. Okay, so we're up here at alignment, and I can click that and I can do align center. That'll snap those to center. Do the same thing with shift to the vertical alignment, middle. Okay, and so I can get those vertically and horizontally aligned. As far as this to this to this, holding shift again, I can make those evenly distributed. So I can come in here and I can say distribute horizontally. Okay, so I can, and now I may have to go back and change some of these things. I can do that and just kind of play with that there like that. So now I've distributed things evenly. The last thing I'll do is I'll select all of these shapes, and I want to make the text the same and center that. So I can go to home, home, and I can go middle or center justification, and I can go center like that. And I can even make the text larger if I wanted. Oh, don't want to go too large. I want to see everything. I don't want to be too small though. And so there I have a nice clear flow. I have a nice clear layout. The last thing I need is a yes and a no here. So I would go to insert. Oh, no, not that. And I'm looking for text box here. I always misplace the text box. Oh, do it like this. Text box, there we go. So I can come in here and just put a text box and say yes. And of course I can do a copy and do a paste and try and get that the same there, and then just do no. Okay, now not too bad. We don't need this outline, gray outline, so I can shift on both of those, and I can go to format, and I can go to shape outline, and I can go to no outline. And I can also go to fill, and I can go to no fill, so it's just clear. So there's basically those words hover over, where I'm have them, and there's no obstruction to what's behind them. So there we go. That's a kind of a quick little demo of how to set up your flow charts and how to organize them, how to get them vertically and horizontally aligned, how to add text boxes, how to modify your text. You could also go in here and you could fill to different colors if you want. I'll leave that up to you. Okay, so if we go back to here, just a quick wrap up. Problem solving a lot of times is systematic, just like an algorithm or a flow chart, and depicting your problems as an algorithm helps you visualize them. And we're going to talk about then later in the semester using pseudocode to bridge the gap between flowcharts and programs that we write and help us to use words and take those words and make them graphics and make those words and graphics an actual program. See you in class.